there and welcome. Today we're talking about rotations about the origin. Now if you've been with me for the last couple of lectures, rotation is just another form of transformation. We've talked already about translations, which we classified as a slide. We've talked about reflections, which is kind of like a flip, as we know from looking in the mirror. And today we're talking about rotations, which rotations, if you think about it, let's take a look at my little pentagon here. A rotation happens as we kind of spin or turn something. Notice that the top point is now the bottom, is now the left, and is back on the top. None of the sides change their size or shape. Still a pentagon, still a regular pentagon. Now that brings me to about the origin. Well, when we're talking about the origin, we're talking about around the origin. We're using the origin itself as a center point. So let's talk about a turn or a spin. And now let's take a quick look at an example here. Well, we've got this coordinate grid here, and I've got my rectangle. So what I'm going to do is I'm just going to do a quick screen grab here and copy that rectangle. Let's pick a point on that rectangle and focus on it. Let's take this point, for example. How about this one here? We'll call this point A, and we'll find its location over 1, 2, and up 1, 2, 3. So the point is 2, 3. Today's rotations are really kind of around the origin. What does that mean? Well, here's my origin. That means the origin, if I could put a pin in it and spin it around, the origin is the only piece that wouldn't move. The whole rest of the grid would technically move. So today we're talking only about 90-degree clockwise rotations, so clockwise. And when I say clockwise, I hope you know that what it means is, here's our clock, and as the day goes on, numbers go around and around, second and minute and hour hands go all the way around the clock in this direction. So a 90-degree clockwise rotation is essentially saying that whatever starts in quadrant 1 ends up in quadrant 4. If I was to take this original graph in this original position and literally pick it up and rotate the entire thing, what is my new position of that original point? Let's do a quick image grab and see if we can figure out what exactly is going on here. So going back here, here is the new point. I'm just going to borrow quadrant 3 for a second. This looked like it was over at 2, 3, or the top left corner of a flat rectangle. Well, I don't have a flat rectangle anymore. So if I was originally going to look at this point, what I'm really saying is that it's this point right here. So I'm going to grab these 3 together, or these 2 together, group them up real fast, and I'm going to turn it back to the way we had just taken the image. So really, what position, what point is it that we've found? Well, we're going to call it point A prime to signify that it is the second of the pre-image of point A. Well, at point A prime, we're at 1, 2, 3, down 1, 2, so 3, -2. And it's kind of fascinating. I look at the 3, -2, and I look at the 2, 3. So maybe there's a rule here that we can use to figure out. Well, what I see here is I have my x comma y. Could I turn an x comma y into something else that helps me identify any future points? Well, my x coordinate is identical to my y coordinate, so I'm going to use that for later. Now my y coordinate will come first of my original. And then I look at my -2 and I compare it to my 2. Now this -2 is the opposite of my x coordinate of 2. So I'm going to write that as a -x. So now what I'm trying to say is that x comma y, after a 90-degree clockwise rotation, becomes y comma -x. And we're going to have to try that out to see if that works. So let's take a brand new shape in a brand new location and see if we can make that work. I've got this brand new shape that I'm going to do a quick screen grab on, and we'll see if we can determine that it is the same rule. Let's now pick a random point, and let's pick this point here. So we'll call this point B, and its location is -1, -2, -3, -4, down 1, down 2, -2. So if our rule stands true, that means our point B prime should be, well, hang on a minute, let's see, x comma y turns into y comma -x. So with all that, B prime should be, well, my y should be my x coordinate, so that's a -2. And the opposite of my x should be my y coordinate, so that was a -4, now it is a +4. So if our rule stands true, b prime should be at negative 2, 4. Let's find out if that's true. Here's my rotation. I'll do a quick screen grab of that, see if we can find the point we expected to find. Well, here we are. Let's see how that turned out for us. Here we are in this new quadrant. Actually, I'll put this down here. The point seems like it was on the left side of this point, so let's see if that holds true. Right here, negative 2, 4, well, over 1 over 2, that's negative 2, up 1, up 2, up 3, and up 4. Stands to reason that b prime would be at negative 2, 4, and it ends up being true. Well, that's fantastic. We're going to have to try that one more time to make sure we can do that on our own. So, let's take this guy out of here and put in a bracket. Here's my L shape. I'm spanning across 2 quadrants. So I'm going to start in quadrant 4 this time. I'm going to pick this point. This will be the point C, which is located at 1, 2, down 1, 2, 3, which is negative 3. If our rule still holds true, x comma y becomes y comma negative x. Well, let's find out if that's the case. Back to our screen. We're going to rotate it. I'll do a quick screen grab again and see if our rule holds true for a third time. According to what we should know to be true, C prime should be at y coordinate, which is negative 3. And then the opposite of the x coordinate, which should be negative 2. Here's our coordinate grid. Let's go over to negative 3, 1, 2, 3, and go down. See that? Negative 1, 2, 3, and down negative 2. And lo and behold, C prime is in fact at negative 3, negative 2. So I hope from this we understand that when we're looking for 90-degree rotations, we really only need to look to one thing. Now that we could physically move the entire graph, or we can follow the law, which is turn your x comma y into a y comma negative x, and you are going to find those points every time.